Assalamualaikum, my name is Nur Syahrin Sahira binti Muhammad Sarif. In another word, conduction is the heat transfer from more energetic to less energetic particles of a substance. And to design this, we use SolidWorks software. So, this is our 3D fin surface of the A-type design. For this type, we choose to design in a square form and have 6 copper tubes at the center of the fins. So, this is our 3D fin surface of the A-type design. For this type, we choose to design in a square form and have 6 copper tubes at the center of the fins. And this is our analysis result after we run the simulation. We got 60 watt for the heat power, maximum temperature 76.8 degrees Celsius and minimum temperature 58.4 degrees Celsius.
Hi, my name is Nurabila binti Muhammad Isa. The aim for these assignments are to let the students work as a group to perform the heat transfer simulation task and to evaluate the graphical analysis on heat transfer for each design. The figure below shows the dimension made for design B is 40 x 40 mm and it is made up from alloy and silicon. As shown below, the simulation for this design consists of 1 base and 10 fins attached vertically. From this analysis, when heat power is applied at 60 watt, it will give minimum temperature at 99.5 degrees Celsius and maximum temperature at 113.8 degrees Celsius.
Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. Okay, today I want to explain about simulation that I draw in SolidWorks. Okay, firstly is we draw a pin. I draw a pin and 6 hooper inside the pin, and the base is for the heat power. Okay. When I apply a 3 watt for heat power at the bottom. For the ambient temperature I apply is 303 Kelvin. For the convection, I put 40 watt per meter cube Kelvin. So the result I get is, for the max temperature is 76.824. For the minimum temperature is 58.448. Okay, as I can conclude, for the heatsink is can use for CPU or any resources at 60 watt because the minimum temperature is around 58. The average for using heatsink, I think in 60 Celsius to 80 Celsius. So at minimum we get 58, so we can use this heatsink. Okay, then I show this is for the ambient temperature that I insert around the pin and seat hooper. As you can see, the green arrow. Okay, for the blue arrow is heat power that I put. Okay. Then we go to dimension. For the given task is dimension, we can use only 40 x 40 for the base. So I use 40 x 40 for the base of pin. for the heat sink. Okay, the length of it is 30. The height of it is 30 and the length of it is 37. The tube that I use is 1.5 radius. So okay, you can see the thickness of the pin is 1 mm and the gap is 1 mm too. Okay, the height of the base is 3 mm. Okay, the height of the heat power base is 1 mm and the length and width for the heat power base is 50 square. Okay, this is the dimension that I use in simulation. That's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Salman bin Muhammad Samiuddin. So I will explain about the design of the second heatsink. As we can see, the second heatsink encourage airflow by angle the fin toward outside, which give more space to air to flow through it. The design consists of two parts. This heatsink and the chips. The heatsink is made up of aluminum alloy and the chips is made from silicon. So the heat power that be supplied at the chip is 60 and the convection through the heatsink is 40 watt, which ambient temperature at 303 Kelvin, which 29.29 degrees C. So let's see to the simulation. So from this simulation, we can see the temperature is spread out through the heatsink, which cool the chips. So we can see the max temperature is at the chip, which the heat source itself, which is 112.08 degrees C, and the minimum temperature is at the top of the fin, is 98.192 degrees C. So that's all for my explanation. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail Najmi Ibrahim. In conclusion, we conclude when the surface on the block is open as the design B, the heat will be easier to diffuse than the even block A, and the material on the block also play an important role because each material specific heat density is different. Thank you. That's all.